Welcome back. This is Adana at the Cincinnati State's Physics Department, and I'm doing an alternate way on how to solve torque using forced angled forces. And you should have watched the first video before you continued on to this one. So we have the same problem. You're fixing a fridge and you apply 12 pounds of force on an 18-inch wrench at 30 degrees, and you're finding the torque you apply on the wrench. I still have my sketch, and I still have my moment diagram without the lines all over it, but that's okay. So, little arrow. So the alternate way to do this is, if you remember, as I said, torque is force times arm, and the arm's perpendicular. But this time what we're going to do is the force perpendicular. So scratch that, put your little perpendicular right there, okay? And this, we're going to treat it kind of like a vector component thing. So I'm going to draw my guidelines. Okay, perpendicular. Okay. And then now that I have my guidelines, I'm going to draw my components. Okay, so now we have components that are roughly perpendicular. And we're finding, perpendicular is the word of the day. We're finding the force perpendicular to the wrench. So this is my wrench, therefore the force perpendicular will be this. Think about that before you assume that it's always going to be the y. Think about it before you do it. So that's why you want to draw your moment diagram so that you can see that this is perpendicular to this, okay? So I'm going to write the force that is perpendicular is this, which, using your trig, is sine of 30 degrees times, your hypotenuse in this case is 12 pounds, okay? Therefore, giving you 6 pounds. So you can even put that in your little diagram, 6 pounds, okay? Does that make sense? I hope so. If not, replay this. So 6 pounds, force perpendicular. We have our arm is the pivot point to the force. If this kept going, it would still be the pivot point to the force, okay? So that would be from here to here is 1.5 feet. Therefore, force perpendicular, 6 pounds times 1.5 feet, and that gives us 9 pound-feet. If you remember from the earlier video, 9 pound-feet was the same answer. So you can pick which way you like better and stick with that, or if you want to do both, you'll still get the same answer. You can use one to check the other even. So we have found our torque that we apply on a wrench. Now I'm going to do an extension of this problem where we have a little child, Sam, small Sammy, is helping you with the fridge, because you know small kids love to help, maybe, and he's running over and they grab the wrench, they're like, I'll help. About halfway between your hand and the wrench head, and they push perpendicular to the wrench opposite of you with 3 pounds. So I'm going to write that in just as a little note. So 3 pounds opposite and perpendicular halfway. Ooh. All right, so I'm going to edit my sketch. I'm just going to do theirs in blue. So about halfway is like right there, perpendicular to the wrench and down with 3 pounds of force. Okay? This doesn't need to be that long, but okay. So that means I need a new moment diagram. I'm going to keep this up here. Just make note of it that this is U. Okay. So new moment diagram. First, we want to find the torque that the child puts on the wrench. And then I want to find the total torque. So, about halfway with 3 pounds of force. Now, a lot of people can make this mistake. It is down, but remember, tails together. So, 3 pounds. Forget this. Okay. That's not straight. I noticed on my camera, that's not very straight. It's supposed to be perpendicular. That'll work. Okay, so the wrench is still 18 inches, but from the pivot point to the force, in this case, is 9 inches, which is equivalent to 0.75 feet. Okay? So, back to this. The force is perpendicular, so we're going to use this kind of equation. I'll just write it underneath. Oh, don't know what that was. Torque of the child is equal to the force, perpendicular, times arm, which in this case is going to be 3 pounds times 0.75 feet, which is going to equal 2.25 pound-feet. Okay, let's talk about direction. Earlier, I haven't spoken of direction before this, but let's talk about it now, because this is downwards, but that's not what makes it negative. If we hold it at the pivot point, imagine this is the wrench, and I push in the direction of the force push, this, if I hold it out, this goes in a clockwise direction. Okay, so if I push down, it goes in a circle, which is a clockwise direction. Clockwise is what makes it negative. Earlier, if you remember, we had it going kind of upwards, which makes it go in a counterclockwise direction, which makes it positive. Counterclockwise, positive, clockwise, negative. Okay? So I'm going to put the negative sign here. Now, if you'd like to, you can draw another sketch for the 2 torques that you have. But I'm just going to continue going with the math. So the torque net is going to equal the 9 pound-feet that you put on minus, because it's negative, 2.25 pound-feet that the child puts on. And together, your total torque is 6.75 pound-feet. All right, so I've done lots of work today. So have a good night or a good day, and do lots of physics. Thank you.